video is on derivatives. Derivatives is basically a way to show the rate of change by which a function is changing at a given point. It can also be represented as an instantaneous velocity at any time t, and is also known as the slope of a curve. The formal definition says that the limit as x approaches to 0 is f of x plus f of x plus h minus f of x divided by h. You can also see a derivative written as d sub y, o sub d sub x, right? It's the change in y divided by the change in x. So, if we look at our rules here, first rule says the constant rule. If we take the derivative of any constant number, f of x equals to 0. So the d sub c, or the d sub the constant, of d sub x would equal to 0. Now, let's first find our first derivatives. F of x equals to 7. So if I wanted to take the derivative of 7, now this is all the fancy work that it's going to make you do. D sub y of d sub x of 7 would equal to 0. Now you could just really get simple, like my next example, and just say y prime of 3 pi over 2 would just equal to 0. So any constant number you have, when you take the derivative, it will equal to 0. Now, if we move to rule number 2, the common power rule. The power rule says that if you want to take the derivative, d sub x, times the x to the n exponent, the exponent now comes to the front, and then we subtract that exponent by 1. So, for example here, if I want to take the derivative of this f of x, well, I would move my exponent to the front, which is now 8, and then subtract it by 1, which will now be x to the 7th power. Even when we have fractional exponents, such as 3/4, we will move it to the front, and that will come, prime of x. You always want to label. This will become 3/4 x, and then we need to subtract our exponent by 1. Now, let me tell you this. Let me write a little extra here. 3/4 minus 1 over 1. You have to have the same denominator in order to subtract. So, if I do that, that gives me 4 over 4, which now will give me a negative 1/4. So, my derivative of this would be f prime of x equals to 3/4 x times x to the negative 1/4. Okay? Now, if you have a square root, square roots are the same thing as well. You want to make sure that you put it in a fractional exponent first. So f prime of x would equal to x to the 1/2. Side note for you, everyone, let me tell you this. The square root of x is always going to be x to the 1/2. The cube root of x is the fractional exponent of x to the 1/3. The fourth root of x, which we really don't go higher than that in this class, it would be x to the 1/4, okay? So you might want to always remember that anytime you have a radical, it will turn into a fractional exponent. So I would do the same thing here. I would bring the 1/2 to the front, and then I would have 1/2 minus 2 over 2. Now, why would I do 2 over 2? Because, remember, I'm subtracting it by 1, and I should already, in my mind, start to think about fractions as it being 2 over 2. So, my answer should be 1/2 x to the negative 1/2. Now, Ms. Parker also just thought about one thing. We never like negative people in our life, nor do we like negative exponents. So anytime you have a negative exponent, you always want to bring that down to the bottom. Now, I'll give this to you. Anytime you have a negative exponent, the old exponential rule says you bring x to the bottom and keep it as a positive exponent. So this answer would be 1 over 2 x to the 1/2. You can also keep writing it back to its original form as 1 over 2 square root of x. Okay? So, that is rule 1, that is rule 2. I am going to also do rule 3 really quickly. Rule 3 talks about the constants terms, or the coefficients, rather. Rule 3, and I'm just going to do rule 3 and 4, okay? Rule 3 and 4 has to deal with coefficients and adding and subtracting. So I am not going to give you the formal definition. I'm just going to do it by example. So let's say you have f of x equals to 3x to the fifth, right? This time we have something in front of our variable, or actual coefficient. You still bring that 5 to the front, but this time now you are going to multiply it when you are doing the derivative. So 3 times 5 is going to give me 15. Then you subtract that by 1, and that'll give 15x to the fourth, okay? So that will be your coefficient rule, which is rule 3. In rule 4, if I have f of x equals to 2x squared plus 3x plus 1. This is all of the rules now put together. So if I was to find the derivative of this, right, I would bring the 2 down. So 2 times 2 would give me 4, x to the subtracted by 1, x, right? Technically, here we have an exponent of 1. So if I bring 1 to the front, 1 times 3 is just going to give me 3, because I should not have an exponent, because that would be x to the what? 0. And anything to the 0 power should just be itself, or 1, right? And what was the derivative of constant function? 0. So if I rewrite this so that you can see it nice and pretty, my answer should just be 4x plus 3, and that's it. Okay? So we will go into more details later on in class, but now you have rule 1, rule 2, rule 3, and rule 4. All right, see y'all in class on Monday.